Well, thanks for the nice intro, and glad to be here and talk and get to share a little bit about what we've been working on in the open source community and how we've collaborated some with Google Cloud team. If you're a designer in the room, close your eyes for 1 second because I'm about to do presentation blasphemy. There we go. Now you can open them. We're on a new set of slides. Here today I'm going to talk a little bit about a topic around notebooks and kind of explain a little bit, if you don't know what notebooks are, what they are, and then how we've been using this to kind of move notebooks closer to a production tool and make it usable with a technology called Papermill. So I think the intro for me was already there. I work on the big data orchestration team at Netflix, and so what that really means I'll explain in a minute. I've done this talk once before, so hopefully this will go really nice and we'll be able to dive a little deeper into things. And I'm excited to kind of connect with you all afterwards and see what your thoughts are. Okay, so to start off, we're going to talk a little bit about what the heck does a data platform team do. This is surprisingly mysterious, even among data platform team members sometimes. So we'll give a little bit of outline of, at least at Netflix, what a data platform team does. The data platform team is really focused around building tools and services that get out of the way of users doing their job. So you have things on the left side of this slide here where you maybe have events or user inputs or system metrics, and this thing that kind of contributes to this vague idea called big data. All that data gets collected up, and you need somehow to get that to the end result of making business decisions around reports or delivering information to individuals or making data models for AI. And at the end of the day, the user just wants to be able to get, as a data engineer or machine learning developer, they want to be able to use this data to make these outcomes. So the data platform services at Netflix is really about building the tools so this is easier and easier for those users to do their job. And so we do a lot of kind of integration of many different systems and platforms and tools so that they don't impede a user's being able to achieve that. So what that kind of boils down to is the platform team, it opens doors, just not that door. All the things I'm going to talk about today are actually in open source projects. So this is around Jupyter open source ecosystem and the Interact ecosystem. They're both sort of building different tools around notebooks, and they're intercompatible. They're not different projects in the whole. And all these things have been contributed by Netflix and by Google Cloud to get integrations into their platforms, into their tools, or just as a general usability for everyone. So real quick, how many of you know what a notebook is? Have used a notebook? How many of you know what the difference between a Jupyter Notebook and another notebook is? Cool, we got 4 people. So I'm going to talk a little bit what the difference is there, and for those of you who haven't used a notebook, kind of what the heck are they? So in the most basic vein, a notebook is, you'll see something like this as an interface. Someone may say, this is a notebook. This is an interface that basically gives you a broken down chunk of code and documentation and logs that are sent and received from some remote REPL or local REPL. So you have some engine that's going to execute code or execute documentation requests and return back some display and outcomes of what happened. So here in this example, you see how this really basic notebook. It's going to import an image, and then it's going to render that image in the notebook and then print out some text. Really super basic stuff, but you can see this is sort of a grouping of code and execution in a nice kind of flowing manner. And you can see this is a different interface for notebooks with the same technology. And these are all Jupyter Notebook interfaces. And in particular, the benefits of using this technology lie around the fact that you have code, logs, documentation, execution results all kind of in the same document. And that this document is shareable to others. This means it's really useful for iterative development. It's really handy for sharing results with colleagues. And it lets you integrate various API calls in one central place that's kind of well-formed. A little bit about what's on this page. What does it represent? What's it mean? So you have things like a status or save indicator in the upper right, or something about the connection to a kernel, which is what's actually executing your code. You have the kind of standard menu items, and you have things called code cells here. So you see this thing I've outlined as a code cell. It's a chunk of text which represents code in a particular language or framework. Jupyter Notebooks in particular are actually language agnostic, though most of the times you'll see them in Python because that's probably the most popular kernel type. And so here you see there's some basic Python code. Maybe I want to load in a model and assert that my model has some version on it. And then maybe I want to pull something out of that model and display it. So the second part that's really useful in notebooks is the ability to display data or graphs or images or HTML right inside the same place where you define the code, so you don't have to jump between systems to kind of see results. The other really neat thing about notebooks is you can rerun just one cell. So it keeps track of the state as you're executing, so you could run everything linearly in a row like we're going to do later. Or if you were iterating, trying to figure out where the display you're trying to get actually is, you can try and look for it, run the cell. If it fails, try changing it, rerun the cell. You don't have to rerun the model load that happened in the cell before. It's already been loaded and you're just iterating on like a live code session. We talked a little bit about already kind of the wins here, but mainly it's this kind of familiar interface for exploring data and exploring problems. So how does this work a bit? So in the Jupyter space, independent of other types of notebooks, the Jupyter space actually is really about defining the protocols about how to communicate between the code executor and the front end or the client that actually wants to execute this. So you'll get something like this where we have some users on the upper left, and those users, yes, upper left for you as well, some users in the upper left, and they'll be using some sort of Jupyter UI, and they have some document, an IPMYB file, which represents the notebook. And then they're interacting through the UI with a Jupyter server, which is communicating to the code executor called a kernel. And it basically just forwards requests back and forth from the kernel on your behalf. And then there's a protocol that kernel follows so that any client and any different UI or interface could do the same thing with their own display. The difference between there and sort of other notebooks, by the way, step back a second. Other notebooks oftentimes bundle the kernel and the server together, so they'll have a kind of just the API layer to the client, and they won't emphasize how you actually execute. Which means it's harder and harder for if you want to make a new type of kernel to just execute a new type of language, or if you want to make a new UI, you have to sort of reinvent more things. Here, the kernel and the UI APIs are all independent units. They are all well spec'd, so you'll see many, many different flavors of UI and extensions like the ones we're talking about today. And that gives Jupyter notebook space a kind of advantage over many of the other notebook options. So we're going to talk a little bit about why these came about and how come people use notebooks, especially if you've never used one and someone's like, I really need to have this notebook in production. You're like, what is this thing? Where did it come from? Where it came from was this ability to kind of explore and analyze data and kind of find a result. So it's really handy for data scientist workflows where I need to load some data that's expensive to load, and I need to iterate on a model over and over and over again, and maybe I don't know what my end code's going to look like. Maybe I don't even know what I should be doing yet. So it makes a really nice way to explore without having to recompute all the very expensive aspects of your code. And this kind of comes into the fact that this makes some really nice qualities for certain workflows. It also lets you record outputs, and it's also an easy to modify tool. I can share this notebook with somebody else, they can reproduce what I'm doing, and they can modify it slightly without having to understand a lot of systems. I can just ship them a file, and they have that reproducibility. But there's a lot of things that make engineering teams kind of frustrated with trying to move these from a development cycle and a scratch pad into a real production system. And some of these things are around a lack of history. If you accidentally edit a cell and save, it doesn't tell you what you edited, and it's hard sometimes to go find out what you actually did, especially if you close your browser or something else. They can be really difficult to test traditionally, so someone will write 1,000 lines of code, hand it over the wall, and ask, or 10,000 lines of code, and ask, hey, make this run in production. And you're like, whoa, I don't know how this works or if it's going to work reliably. It's also a mutable document, so you're always editing it in place in traditional UIs. And it becomes kind of hard to collaborate on in this sense, because two people try and edit that document at the same time, you can run into a lot of issues without extensions on the protocols. So one thing we did at Netflix was try to fill some of these gaps. We had a ton of users using notebooks, and the things we saw was that instead of trying to push those users away from using notebooks, we said, okay, we've got a sizable number of users who all love working in this environment, and they're having a lot of friction and pain moving from that to the systems that are already in place. So they oftentimes had to rewrite all the work they did, or had someone else rewrite all the work they did in another place in the same exact pattern they already solved. So some things we wanted to do was really help with improving the fact that these notebooks aren't versioned, so it's hard to figure out what you actually ran in a particular time. The immutable state, and they can't really be templated. It always requires a human to go edit from the UI and change a variable to rerun it, which is not a very programmatic pattern. But some things we really wanted to preserve was like results linked right next to the code, good visuals, the ease of sharing. These are the benefits, and we didn't want to move away from them. So we worked on this library in the open source called Papermill. And Papermill is in this GitHub project called Interact, which has a whole bunch of utilities and tools around notebooks, particularly Jupyter Notebooks. And from a high level, it sort of works this way. It's a program which runs like a client, much like a UI would, and it's going to take something as an input notebook in some path, either on S3, in Google Cloud Store, like in this example, in your local file system. And it's going to parameterize and run that notebook, and then it's going to output it to an output location that's independent of the input. So in this case, we maybe have 4 different runs we've run, where we've run the same notebook 4 times with a different run each time. And how would this look in code? So it's actually a really simple interface. So you don't have to get really complicated with it. Here we're going to do some examples where we run Papermill against some Google Cloud Papermill demo with some input notebook, and we're going to basically output it to a new place. And here we're just running the notebook verbatim as is. We said, hey, we want to run this notebook, so what's Papermill doing? It's actually executing the whole notebook end to end from the beginning to the very last cell. And as each cell executes, if no errors occur, it continues to the next cell. And as each cell executes, it's saving the outcome into the output location. So you get incremental results as it's going, and it also can log out live what's actually happening, even if you have some interruption in the middle of a cell or some hardware dies. But if you run this where we have some output run of the demo and we have demos out, you see like a folder in your Google Cloud that has these output runs. Maybe you're running once for each day, so you put the date into your output path. And now you actually can see a history of what you ran every single day. You didn't mutate the input. Your output is isolated from your inputs, so you get some nice immutability guarantees. You also get some version history in the sense like if you're running things, you can see historically what you actually executed. But that isn't where we stop, because one of the other things that we can't do is we can't go in and edit like a human and change a parameter or a variable inside the notebook and then expect that notebook to run. So when someone gives us a notebook, we actually need the ability to templatize it, which is add parameters. So in this case, you can see we're going to run this input notebook and pretend this is a notebook which goes and maybe counts the number of clicks by device in a certain region for some website you've maybe heard of. The notebook that you're running, we would have this default parameter cell in here where you would identify this is my default. You can set the region to US, devices to PC. So if I were just to run this notebook without Papermill, it would run and say, hey, I'm going to count everything in the US that was a PC that did a click on the website. But then when we parameterize it in this way with Papermill, you're going to see that we've overwritten region devices by inserting another code cell. So the way Papermill works is it'll generate your inputs, create a code cell out of those inputs, and inject that into the notebook as though if it were a user input. And then when it runs, your outcome actually just has that right in as code. So when you read it, there's going to be the cell with the comment saying parameters, and then all the parameters that got injected by the system on your behalf. And also, you don't have to be executing this from Python. Excuse me. You can also execute this in command line, which is actually probably a more common pattern, though if you're trying to extend it, you'll want to extend things in Python. But here you can see the same exact command where we did this Google Cloud notebook input-output path. We can do the same thing with command line, but just saying Papermill as a CLI, which wraps that other call. And then you can pass in parameters in any sort of JSON format or as individual key values. Technically, -y is for YAML, so you can give it YAML as well, though here we're passing JSON. So let's do maybe what would this actually look like if I were calling it on the command line. So it'd be something like this. I run that command that we ran. You're going to see the printout of, hey, I'm grabbing an input notebook from here. I'm going to an output. And then you'll see this progress bar going that kind of prints out progress is going and the rate at which it's processing. It's configurable about which of these things you want to render by default, but it gives you some basics about what's actually executing as it goes. And you can even put it in a log mode so it'll print out all the logs about each cell as well as saving it into the cell. If we ran that same outcome and we want to go look and say, hey, what's in your Google Cloud, we just ran that, and actually the code I ran up there was the exact same, basically the exact same code, and then I point to this Papermill demo bucket, and you can see we have the outcome and the input separated. Input has 993 bytes because it didn't have the image baked in, and then the output has 35 kilobytes because it was that original notebook we looked at that prints an image. So how does this change the picture of the interaction with the tooling under the hood? Like, this is sort of replacing this whole stack? Not really. It's actually just a different client to talk to the Jupyter kernels. So it's following the same protocols and specs as an API client would, or any other kind of codified interface you want to make or user interface you want to make. And because Jupyter has these really nice specs about how to communicate between the REPL and the interface, Papermill can act like any of those clients and execute. So when it runs, it'll actually launch a kernel manager, which will go find the kernel by name, start it up, run all your code, shut it down. And then the only other difference is that the read and write, we're reading from one source and writing to an outcome source, or outcome destination. And that's a little bit different than the maybe development cycle pattern, but at the end of the day, you always have an IP and YB file that you could load in any system. If you look a little deeper under the hood about what this actually looks like, there's a few modules that go in here. There's sinks and sources, which can be any kind of schema destination, so things like Google Cloud, S3, Azure, file system, HTTPS, those are all baked in. And then the parameters here, you can pass in any kind of JSON-like value, and those are extendable. So if you want to have more customized things for your platform, it's very easy to make an extension of how the parameters get passed in. So you could do things like, with table references, actually load the table data on behalf of the user. So the other thing this kind of enables is the idea that you might have a notebook template. Let's say something that's a learning algorithm, and you want to adjust how you actually run it. You can run that and parameterize the notebook differently for each run. And then you can run that notebook and have a documented outcome that has visualizations, logs, and outcomes all in one place for each parameter variation from your template you started with. This is really, really handy for machine learning patterns because oftentimes you want to have a template, explore a little bit, find a pattern, but then you maybe don't know what parameters you should actually use in production. So this is a way you can fan out that notebook without rewriting it along many different parameters. And the end result here is you can also then kind of see what the result of maybe a confusion matrix or some other accuracy score on the outcome is for each of those notebooks. So there's a few aspects of notebook execution that this extends to. Part of it is we've extended the use case to other types of users, and this is actually where Netflix was really targeting with some of this Papermill investment. Before, we just had the data scientists had a nice iteration place that didn't fit very well into production. And now we actually have expanded, so now analytics engineers and data engineers are using notebooks more and more because they get the benefits of sort of logging, they get the benefits of associating the thing they're executing to outcomes, and they can kind of iteratively develop. They all kind of have an iteration cycle that looks somewhat similar, although I'd say the data scientist is the most involved in terms of iteration cycles. But now they can develop in those notebooks, and all of those different user profiles can use Papermill to then schedule that on the platform or run it programmatically at a later time for people. So one example of this, there was a blog post which is linked on the slide here around how to use Papermill with TensorFlow on Google Cloud to actually execute your notebook with GPU instances or other types of configurations. So here's just a little snippet. I had to cut a little short fit in the slide, but the blog has the full code to execute this. But you're basically just going to run your Google Cloud Compute instance create call with an instance, and then you're going to pass in your GPU count and type, and then you're also going to say, hey, my startup script is this Papermill input path, output path, and you could imagine adding any kind of parameterization here in that you would want. And then you can tell Google Cloud to delete that instance when it's done, and this basically has now made a orchestration for executing your notebook on top of another set of hardware, including hardware that you might not have access to in your local dev. The other thing too is this is all open source code, so all the things I'm showing aren't proprietary hidden behind walls. The Google Cloud storage was actually merged into the open source, so it's very easy for anyone to access with their tooling in the Google Cloud. S3 and Azure are similar stories, and it's really easily extensible to any other scheme you want to add. We'll talk about how to do that in a minute. And the whole Papermill repo, which by the way had the 1.0 release, actually went out today, which was feature completeness and all the kind of little things upstream finally got finished and merged into releases. So it's a really nice, clean repo to read now. But all of it is plug and play. So how you read from sinks and sources, how you actually execute the notebook, and how you apply parameters are all registered classes that you can register your own custom versions of. Say, for example, we want to implement an SFTP handler. Say we have some files in SFTP because that's where someone has some notebooks. Or they want their notebooks to land there because you need to share it across some B2B channel that still is using SFTP. To implement this would literally be all the code on here. If you implemented read and write and then did the setup tools here, this would be all the code to be able to call the command at the bottom, which is papermill execute with an SFTP scheme. It has this entry points pattern you could do where you can register in your own setup pie an entry point about how to register an I/O interface in, and for the other interfaces have a similar pattern. So the code to actually execute things, if you read the whole repo, it's really short now. There's not very much code in there. So it's pretty easy to grok what it's doing and to add new things. All right, so one thing I want to talk about is actually the failure mode is actually really nice with notebooks. Traditionally, if you think of how would I have a bunch of scripts that maybe I didn't quite productionize and put into a library, or maybe it's calling things across 3 different systems, how would I actually understand what went wrong when it fails? And this is what keeps people like me employed, because it's a hard problem, so we can go build solutions for people. But one of the nice things is with a notebook, if you failed with a notebook, and we call that same pattern where we fan out over some parameter, the failed notebook actually has a really rich source of what happened, how did it go wrong, how do I reproduce the problem. You get all of that captured in that notebook. Because it failed, it'll actually still save the outcome, but it'll say, here's the stack trace, here's the cell that failed, here's how the code didn't succeed. And your parameters, when you're running with Papermill, are already baked into that notebook, so you don't have to reparameterize it. It'll run exactly as it ran when you were scheduled or running inside a platform. So here, for example, we have this notebook. These are some of the advantages I just talked about with stack traces and rerunability and execution logs. But let's say that notebook we just had, we failed and it crashed. Well, something we can go do is go find the issue in the notebook. Say here we found this cell execution number 12. I've cut out middle layers. Has some sort of HTTP connection failure talking to Spark. We can go load that notebook into a notebook dev, iterate on it until we fix the problem and identify what's actually wrong, and then we can ship that fix back to the upstream notebook. In this case, for example, we had a Spark job was defaulting to a host name that didn't exist. So it's trying to target some Yarn cluster that doesn't exist. So maybe we need to tell it where the Yarn cluster actually is. And now the job actually succeeds and we can push that change up. But we reproduced the exact problem and we didn't have to go and ask 5 systems what went wrong. So what this kind of very simple change to how you execute notebook with a client that isolates the inputs and outputs gives you is that you get immutable inputs if you're not changing your input that you scheduled or are executing on a programmatic basis. You get immutable outputs if you're saving your output to a unique path. For example, we put to whatever the user's execution context plus a GUID for every single run, and then we associate that back. And we put it into some place where it's read-only, so users don't have access to go edit it. That means you have very good reproducibility and audit history about what actually executed. You also get nice parameterization of notebook runs. So no longer do you have to have a big block of instructions for the human to go change a notebook. Like when running this, change these 3 lines in this cell and then go change these 4 lines in this cell. You don't have to do that anymore. You can just parameterize it and templatize it so the user can just pass in parameters. And then the other thing too is the configuration of sourcing and syncing. This means that you can get interface right into the platforms where you already share files or where you already have hosted systems without having to rewrite, the execution and wrap it in your own copy and move and shift. So, given all that, it also makes a pretty compelling argument for being able to test notebooks better with Papermill. As opposed to before, with testing, it was usually ship it to somebody and have them run it and say, yeah, this is good, and hope they were right. So in terms of notebooks, one thing to note when you're talking about testing of notebooks is notebooks make pretty terrible libraries. They make great integration tools, but if you have a ton of library code in there, they're pretty hard to make reliable and know that you can share and make it reuse. I'll talk about what that means. So they make a good integration tool because notebooks are really good at connecting different pieces of technology, logging how it actually ran, building a result, or taking some actions on disparate pieces of technology without having to leave an ecosystem. but they're kind of unreliable when they're really complex or they have a really high branching factor. So when you have a notebook that has 15 conditionals inside of it or many different functions and loops, it can be really hard to reason about if this thing's going to run. Now the traditional path here is with code is you would go unit test each of those pieces and break them up. With notebooks, since unit testing is a bit hard, we actually kind of, at least at Netflix, have adopted some of these development guidelines for the more critical things. This is keeping a low branching factor. Short and simple is better. Try to keep the one primary outcome. So if you have a notebook which does 5 things, maybe consider breaking that into 5 notebooks and have 5 notebooks that do one each doing its own job. And try to, I put this in parentheses because we fail at it too, leave library functions in libraries. So if you get a really complex notebook and it's important and you want to move it to production, move that code into a library that's shared across your notebooks. Maybe talk to your, whoever's helping support you to make that happen if you don't know how. But we do still get advantage of something we couldn't do before, which is integration testing. So if you want to write an integration test, you basically just want to write exactly what the user would have run, a template call into your notebook. So say we have that Spark template that we showed failing earlier. We want to write an integration test because it failed for the user because they didn't have a cluster host defined, and we could have easily caught that the default value was going to fail. Here what we can do is run that same Spark template, and then we're going to do some test run output. Maybe we would automate this and you have a test run ID in there. And then what we're going to do is pass in a fake region, a fake run date, and a debug flag just in case for notebooks that want to be able to maybe dry run their execution if they're in debug mode. And in this case, we're going to be targeting this region that has tons of users called Luna. We're going to pick a run date, and maybe that doesn't really matter, or we'll fix it to a hard-coded day. Really? Is everyone awake, by the way? I just talked about, cool, finding people on the moon, and no one even checked. Okay, cool. We've got the, here are parameters, that got passed in. You see region got assigned, the run date got assigned, and our debug true. And in here, this Spark SQL that we're actually running, maybe it's running a particular query against an output table. And now we're using our parameters, we can reorient how this runs and run it against dummy data. So we'll do this a lot where we'll run integration tests at Netflix where we'll run all the templates and we have default tables with some known potentially problematic patterns or just the simplest thing we can make. And then we run the same template the user is going to use in the same way they would use by targeting that table or that piece of code. And this gives you a really nice way to say, hey, end to end, this notebook runs well. I know all the defaults make sense, and I know I can parameterize it in some way. You can also, if you have a DAG execution, you can do things like run the integration test and then have a follow-up unit in your DAG that says, hey, did this actually write data if you're concerned about that? And you can kind of branch. It gives right into the wheelhouse of integration testing. If you've ever kind of dived in how QA thinks about testing, it gives a nice breadth of coverage for notebooks in that space. So it means is what are some guidelines about how I test my notebook? Unit testing your notebook is hard. The tooling out there isn't great, or even if you had good tooling, it's a little bit cumbersome because how do you had this one document you could bundle and send to somebody, but now how do you bundle it with unit tests? Do you put them in your notebook and make it really cluttered? Do you put it alongside? Then why don't you just make a library anyway? There's some hard conversations there. So what we actually ended up doing was saying, hey, use notebooks for what they're good at, which is integrations or reproducibility, and try to follow these guidelines to make sure that you can trust that they're going to work. If you have a simple one-pager of a notebook, one integration test is probably sufficient. You'd be fine. If you have something that has maybe a little complexity, and maybe it's 2 pages of code on your screen, maybe a couple integration tests for a few of the patterns that could go through it to make sure you cover more of the lines usually covers you pretty well, and you'll be pretty good for production use cases. If you do a really complex notebook, I wrote my whole ML training, loading, saving, and 3 different model iterations in the same notebook, and it's a 20-page document, one, maybe don't put that in prod. If it's critical, move some of that code into a library so that the shared code between your model execution can be loaded in all your notebooks, and then your notebooks get nice and trim, and it's more about integration where your library is one of the integration pieces. And then if you can't do that and you still need to get it running, trying to get one integration test per usage pattern of how this would be used at least gives you some confidence. It's not a silver bullet, but it gets you further. And one thing I want to really emphasize too is that I've talked a lot about Papermill and how you can use this tool to change notebooks. There's actually a ton of other goodies in the ecosystem because it's all spec and protocol based. Notebooks actually have a whole rich environment of libraries that give you different capabilities. And oftentimes in today's world, a lot of notebook teams are being formed are really about how to collect these goodies and put them into a platform that works for your use cases. So a lot of tools that you probably haven't heard of but are used by platform teams all around that I would encourage looking into. ME-Convert is something that actually Papermill uses, but it can have other export forms, so you can make HTML or PDF outcomes of your notebook. Commuter is a read-only interface for notebooks, probably the most useful out of this list because it makes sharing a lot safer and a lot easier. You don't have to have a whole notebook server up just to share the results of an execution or of how you're planning to do something. And there's a few others in here, so which I'll talk about for a couple minutes. So Scrapbook is one of them. Scrapbook is another repo that I've written from scratch that basically pulled some functionality that was in the original Papermill implementation and put it in its own bucket. And what this is really trying to do is as a tool, Scrapbook is intended to kind of complete the story arc of notebooks as a function. So with Papermill now, you have an input notebook and you have Papermill, so you have like the function you're actually going to run and you have parameters as the inputs. But your outcome today is still a notebook. So when you outcome a notebook, it's still mostly human interpretable, not machine interpretable. One of the things that this adds is the ability to save results by name in your notebook and then recall them. And what this is really useful for, say I ran that notebook that was an ML model and I want to iterate all my parameters. One of the things I might want to save is like the confusion matrix result, and then I want to collect all those confusion matrices and find the parameterization that was best or fit some criterion. This lets you do that pretty easily without leaving the notebook. I encourage you to go look at the GitHub to like look into more details about how that works. But here in this example, inside the notebook in the first section, we're importing Scrapbook and gluing our model results. And then later outside the notebook, maybe after we've executed it or in another notebook, we're going to read that outcome notebook and then go collect the model result by key. And you can also save things like graphs and recall them. So one of the things that's really handy is if you have like a performance graph, you can actually save a performance graph alongside your confusion matrix result. And then when you find the confusion matrix you like the most, you can actually go render the graph for that run as well and not have to re-execute it. Kind of a handy little tool. Take a look. It's a little bit early in sense of where it could go, but it has like full featured capability for the things I just described. And I talked a little bit about Commuter. Really highly recommend looking into this one. This is the interface for Commuter. This is our Presto template for how to execute Presto jobs. Notice it fits on one page. It's nice and clean. There's almost nothing happening. But it's really handy because these calls here, we have like a schema input, and then we have a gaze here that prints out the job information, and then a monitor at the end. Here we can share this notebook template with users, and when they actually execute, they'll see this but parameterized with their logs in there, and we always share through Commuter to the users, so they have a really nice way of seeing what happened without the risk of editing anything. So I've talked a lot about the open source and kind of hinted about how we've used it a lot. One of the things at Netflix in about a year and a half ago when we kind of started really diving into this adventure, there was this strategic bet made that the large swath of users that we have that we were hiring the most of, which were analysts, were actually using notebooks instead of other tools, that us leaning into making notebooks easier would have benefit to the company. And then we kind of took it a little further, almost to crazy levels, where we were doing a new scheduler project. We decided to make every single scheduled job be a notebook, which might sound extreme, but actually it played out very well. Because what we really did was we made templates, and the users didn't even know they were using notebooks at first. They say, I'm running a Spark job, I'm running a transport to Druid. They're just giving the inputs and parameters for that type of job that's schemaed like any other job definition. But at the end of the day, we always translate that to a notebook. This has made it so it's really easy for anyone to debug what happened. I'll even put this to the point, we had a manager of a team who hadn't written code in a long time, and his on-call person, this is a machine learning team, his on-call was out sick, and one of their critical jobs failed. And he told me afterwards, I didn't even know he did this, but he said, oh yeah, I got paged because he was sick. And I went and looked at the job, and it had this notebook thing. I didn't know what it was. I clicked on it, and it had this really nice visual, and then it told me exactly what the stack trace error was, and I read it, and I understood what was wrong, and I actually fixed it, and then re-ran the job, and it worked, right? And like that was a manager of a team was able to do that. Like it lowers the barrier quite a bit on understanding like what actually happened and what went wrong. So that's kind of a fun thing. And since then, since we started this project, we've moved like over 10,000 jobs that produce like on the order of 150,000 queries a day to all be running in this notebook framework. And we've had pretty good success being able to support that. Cool. That's what I have for the presentation, and then I think we have some time for questions. But yeah.
I would like to ask about the performance and potential impact of the performance compared to running a clear Python code. Is there any difference, or?
Yeah, so the question was, is there any difference between running pure Python and running a Python notebook? The answer is pretty much no. In reality, this is all, the only thing you have is a little bit of startup time in order to launch the kernel, which is on the order of a second or two. And then after that, you're running Python code with IPython at the same way you would run Python code normally. So there's no real performance impact. Yeah.
Does the kernel have a built-in compiler or interpreter, or is it using the system's interpreters?
The kernel is responsible for making sure it can execute the code. So in most cases, like in the Python case, it's wrapping IPython, so it's launching a process side. It's built in.
So if you want to make sure you're compatible with a server's version, you have to do something else.
Yeah, oftentimes people for like version things like Python or Scala or some other, or R if you're using it, they'll name their kernels with the version. So you'll say, I am an IPython version 3.7 kernel, right? So you're running Python 3.7, that's the standard you're executing against. Much like you would say, hey, execute this job with Python 3.7. Same way with Scala and others. In Spark, they'll oftentimes put the version in the metadata of the kernel, so it's very clear what you're executing against. How it chooses the kernel is actually inside the notebook. It saves when you run it, or you connect to a kernel, it saves in the metadata of the notebook. I ran on this kernel. When it runs, it tries to find exactly that kernel, and then it has fallback mechanisms if it can't to try best effort if you want.
So before...
Sorry. All right, you and then you.
So before notebooks came to Netflix, so what was the other alternative for doing the same thing?
Yeah, so what was the alternative to doing what we're doing with notebooks now? Well, one is we had a really old scheduler, and it was a real pain to debug it. There were like 2 guys who could do it, and everyone else was like, hey, this went wrong, and those 2 guys got really, really busy. So on the scheduling side, that was the story was kind of like unscalable for what we had. We could have solved it in other ways. On the kind of iterative cycle and like moving things the prod side of things with notebooks, the story was the story that's in a lot of places today, which is every time you wrote something in a notebook, after you got done, you got told to go rewrite that someplace else. And sometimes you did a good job of that, and sometimes you threw it over the wall data engineering, and sometimes they did it, and sometimes they threw it back at you. So there was kind of a lot of friction, and it was okay at a certain scale, but we were clearly seeing the warning signs that like the user base that's doing this is growing way faster than all the other user bases. So rather than running away from the technology they like and use, we wanted to move the platform closer to them so that there was less friction. At the back there, sorry, he's got his hand up a couple times.
Is there a limit on the amount of computation that fits in the kernel? So can you do like distributed training?
Yeah, so the question is there a limit on the computation within the kernel? It has the same limits as any other execution process. So oftentimes you're executing when you schedule this or run this on a platform, you're running usually in some container that has some resource limits, and those are your limits. It's the same as any other process.
When you copy and save several Jupyter runs, do you do the diff and save only the parts of the notebook that changed, or do you save everything?
No, it saves everything. It's an output totally. What it does when it runs is it actually reads the IPMYB. It's a JSON schema. So it loads the IPMYB file in, verifies it matches the schema for version 4.4, then it executes it in memory against it, updating, and every time it saves, it converts that in-memory representation to an output totally independent of the input. So it'll actually dump it.
So if I change only like 5% of my notebook, iteratively trying to experiment with something, but it will also save 95, the remaining 95% it will save multiple copies.
Today, every time you save, you're saving the whole notebook. So that's something that'll probably change in Notebook 5 format. With some options for being a little more scalable in that sense. Usually it's not a problem unless you save really, really big displays. Like I save a gigabyte of data, you're going to have a bad, like if you say print and it's a gigabyte, you're going to have a really bad time. Of course, you'd have a bad time in most interfaces, but it's a little worse in notebooks in that sense. But yeah, every time you save, it saves the whole document. The question over there.
So if you use a Python file, you have a lot of tools that help you write good quality code, like Pylon and
Yeah, I would encourage you to bring some of those tools to notebooks. There are a few, like linting and like a lot of the UIs have some built-in stuff around certain languages. Though since it's a polyglot system, a lot of those languages lack nice autocompletes, nice like linters and things like that. So if you jump over to something like Scala, it's still kind of rough. It's getting made better because there's companies investing in it, but like R Studio still does better than R and Jupyter in that sense. I would say those tools can be integrated, and I would encourage to bring those tools to Jupyter. There's a few places where they already exist. All right, we got a bunch. I think you were next.
So are you able to handle the cases where the kernel actually fails? For example, the code makes the kernel run out of memory. Are you able to like save the last execution that was up until the point when it ran?
Yeah, so he's talking about, the question was, when things go wrong, like the kernel runs out of memory, what happens? Or is it handled well? Well, the nice thing is with Papermill 1.0, which released, it now has a better OOM handler, so it'll actually raise that it ran out of memory instead of running forever, which it used to do sometimes, which is the worst thing it did out of things that were bad. But in terms of like story arc, what'll happen is when you actually run is it won't save that final execution. You'll see if you load the notebook, it'll say executing with Papermill ... and it'll be stuck in that mode. Mostly because the processes die and you don't know how to recover. But what you do get is when you run Papermill, we run it in production, we run with -- log outputs. And that says every time we would get a message we were buffering the save in the notebook, we log it out right there. So we at least have the container that was executing Papermill has all the logs. So if something really catastrophic happens, we can always read the logs from there, even if the cell on the notebook failed. One thing that would be nice, and I think we should probably invest in that more, at least in our platform, is when it does out of memory of making a link, like rewriting over that notebook to add a link back to the logs or inject the logs afterwards. It doesn't do that today, but it would be pretty easy to add. Cool.
Do you save your notebooks in version control and then how do you diff it?
Yeah, so the question was, do you save in version control and how do you diff it? The answer is I save my stuff in version control. Not everyone else does. I would say that diffing is kind of painful. It's been getting better, actually. There's a few tools out there. So mbdime is a tool in Jupyter for diffing notebooks. It's not so integrated with Git everywhere, but there's some efforts there. mbviewer is a nice, it's kind of got an open source side and a closed source side for doing GitHub viewing. And I encourage you to go, if you don't use GitHub, they've got issues for other Git systems that I've definitely +1. Go poke them and tell Bitbucket to go add an API so you can do the right thing. In terms of local diffing, so the reason why I asked is notebook diffing is really ugly because you're diffing JSON documents. They are pretty printed at least, so it's not like all one line. But when you want to read it as a human, you usually give up after a bit. So the effort with mbdime and other places to get integration to your like places where you do code reviews and render the notebook as a diff, two-sided diff, rather than reading the JSON raw. Today, I read the JSON raw sometimes, and it's unfortunate. You had a follow-up question.
Yes, so you mentioned that you save it in the GitHub, in Git.
Yeah.
The others in your company do not. So what's the reason for?
Some of that's just like the analysts and even some of the data scientists. Like Git's a new thing. Like they maybe just learned SQL. They can do reporting. They know Tableau. They know some of those interfaces. And Git's kind of new, so it's kind of a scary thing to get into. And also sometimes people are just lazy because humans are humans. So like while yes, you should always use Git and version control, the reality is sometimes people skip that step if they don't think it's too important, and then later it becomes important and they forgot to do that. What we are trying to do there's one of the tools I mentioned there is called Bookstore. Bookstore tries to give you linear versioning, so every time you save, it kicks off a version to, right now it does it to S3. A blasphemy in this room, but Google Cloud, you can plug it in, make it happen. But Bookstore is a way to get you some linear version control without having the user have to do anything. Yeah.
So let's say you have a notebook and you want to make it into a Python file. Is there like an easy way to do that, or do you just have to copy?
Yeah, mbconvert -- to Python. No, oh, sorry. The question for anyone that was online that couldn't hear was, can you convert a notebook into a regular Python file? And mbconvert is the tool to do that. Yeah.
So Jupyter Notebooks are open source, so can anyone contribute to it? Or if I wanted to contribute, how would you start up?
Yeah, the question was, Jupyter is open source. Can anyone contribute? Do we have like a donations please or a big don't enter sign? No, we don't. So I'm on the Jupyter team as well. And yes, we try to be as friendly as we can to pull people in. there are a few of the packages or code paths that could use some more professional love. So we do also try and tag issues with like new user friendly. Papermill has had a lot of like brand new contributors contribute to Papermill specifically. Matter of fact, that's actually how Google Cloud, they just kind of opened up a PR and said, hey, we really love to get Google Cloud working with this, and that went really easy. So I would say it's open, and there's a lot of forums both on Discourse, Gitter, and the Google group are all good places to kind of engage if you're trying to find a place to work. And then Interact also has a Slack channel for lots of things. You can go ask questions there.
Can I enter those parameters as a URL parameter?
As a URL parameter, like go fetch them from a URL?
I put a question mark and then put parameter A, parameter B.
Not sure I quite follow the question.
I mean, when I open the IPython notebook in the browser,
Uh-huh.
there's a URL for that, right?
Yeah.
So can I add extra parameters which the script consumes as a...
Oh, I see. So he's asking when you load a notebook in the UI, can you add query params to parameterize your notebook? No, because that's not actually running through the templating path at all. That's like the UI human path. There will probably be extensions to make it easier. Like some of the interfaces now have actually just made like add a notebook parameter cell as like a first class thing into the notebook interface where you just click a button and it builds a cell for you. Though traditionally today what you have to do is, so the way it will choose where to put your parameters and how to apply them is it'll look for a cell with the cell tag parameters and it'll treat that as the default. So anything in there it thinks are the defaults and then it'll inject after that. If it doesn't find anything, it'll just put it at the top. But from a query parameter point of view, it's not really an interface you're parameterizing there because you would just write the code cell yourself or write the default tagged cell yourself. It doesn't automatically do that for you. Cool.
This is more of a feature request. So, do you have the timing information for each cell? Because if something fails, you want to know whether it took 20 minutes to figure or it took 2.5 hours to figure.
Feature request was, can you add something so you can keep track of how long cells took to execute? If you run the Papermill, it does that.
Oh, it does it already.
Yep.
Great.
It might be necessary, but if it does fail, there's no way to start to continue execution for where it failed. Right? From like suppose not fail, but let's say the kernel is interrupted. Like, is it like with the metadata from the cell, you can still see whether completed, whether it's pending or running. So suppose something was pending. Can you start or continue execution where it left off?
Basically, the question was if a kernel fails and your Papermill execution stops, could you reattach the kernel and run against it? Today, with tools as is, it would not do that because it shuts down the kernel when it fails, or it attempts to because the kernel may already be dead. You could write some code. It would probably take on the order of 50, 100 lines of code to make it not do that. And actually that extension part where I said where you can plug and play the IO thing, so like SFTP, you can also plug and play a thing called engines. So it has the ability to register custom execution engines. And you could register a custom engine that would hold on, like you could monkey patch to overwrite the way mbconvert shuts down the kernel and like not shut it down. So maybe have like an engine called debug or interrupt, and then you could run that version of the engine when you execute, and then you could leave it up so you could reconnect. It would be a little complicated from an interface point of view, but it's physically possible, and the out of the box doesn't do that.
So in one of your slides, you showed that there are Jupyter servers which execute the code that is in their notebooks. So who maintains those servers? Whose job is to keep those servers up and running?
Yeah, so the question was in the architecture diagram, there's these Jupyter servers. Who runs these servers? What do they do? Who owns them? The answer is usually a notebooks platform team. So many places have a notebooks team. Google does here, Netflix does, most your big vendors do. They're usually the ones who are hosting the servers that are running everything and figuring out with the rest of the platform how to orchestrate that. So how to isolate resources or on demand. So there's a few tools in the open source that help you with this, like Jupyter Hub is a way of divvying out things. And I think that's a pretty rapidly evolving story. But generally, it's usually a notebook platform team that's managing the servers, and then when you click launch my notebook or you try to load a notebook, it'll like dynamically allocate resources for you someplace. Depends on the platform. Some platforms you have dedicated resources or shared resources. It kind of lets you do what your platform thinks is right. Also, I don't know if people are on the remote call and want to ask questions, if that's possible, or people...
That is no worry.
Okay. Sure.
So how do people go around like building more complex pipelines? So for example, you've got notebook A that you want to feed into notebook B, then you want to send out to a couple of notebooks and collect the results and go to notebook D or something. So the normal API has only the execute notebook. Do people like run scripts to like execute these sort of complex things, or is there some tooling for that?
Yeah, so the Papermill and the Jupyter side, basically we just made it so it's very easy for any scheduling tool that has DAG execution to do its job well, which is doing DAGs and linking things together. So we use an internal scheduler tool that we beefed up, and we basically have two job types. We have run a container and run a container with Papermill. That's like the two job types. But in reality, from the user perspective, we have like many templates that we default in for them. But there, we really leave it on the tool that knows how to schedule, not knowing what Papermill is and just executing, doing that job well. So like an open source example that is Airflow. If you have Airflow, it's very easy to integrate Papermill and Airflow. A lot of people do that there. Luigi or some of the other schedulers can do it very easily too. But I would say in chain of responsibilities, I would let schedulers do scheduling well, and DAG executors do DAG executing well, and Papermill do the execution well. Yeah.
You had some user personas on one of your slides, like data engineers and stuff like that. All this we sort of found the entire like notebook workflow iterating to parameterizing to orchestrating, or is there like handoffs between different?
Yeah, so the question was with the different personas we have, what's the life cycle of a notebook with each of those personas? Is it handed off or end to end? Depends more actually on the team or how that organization operates. So the tooling we've built kind of spans a bunch of orgs at Netflix. Most of the time, people own end to end, I would say. Like they iterate on the notebook and then they want to schedule it, and then we ask them to kind of follow some guidelines, or like if you want to burn yourself and do something bad, you can. We kind of have a hands-off approach at Netflix, so it's a little different than some places. I would say a few teams, and probably more of the iteration cycle outside of Netflix, is probably more the handoff model, which is the traditional model. Hopefully this tooling helps lower that friction some, so the handoff is more to like review and do more like a code review and then templatizing it, rather than rewriting someone's work entirely.
My notebook input be the collaboratory, Google Collaboratory notebook?
Yes, so Google Colab is a Jupyter, follows the Jupyter specs. So if you have a Colab notebook, it will run with Papermill, and you can load it in any other notebook interface that's a Jupyter notebook interface. Colab, by the way, if you're not aware, is like one of the Google provided notebook interfaces for managing notebooks inside Google Cloud. Or not inside Google Cloud, but inside Google.
Is there a better visualization tool for video in notebook or for Papermill?
Is there a better visualization tool for video in notebooks? There's a few efforts that have been there. It's more about the component that renders. So the way, if you actually look at what's being sent as messages to and from the kernel, you send code to execute, and then asynchronously you get back these like different messages. One of the messages is called display, and display has a MIME type, much like any other like front-end rendering system would understand. So then your UI can implement MIME type renders. So you can implement a nice, like a better video render by implementing something that responds to that MIME type and then plugging that to the video editor player you like. So there's been some efforts in a few UIs of making better video. Mostly those have been closed source extensions of Jupyter, not so much in the open source. I'm not aware what the current state is for open source video rendering niceties, but if you want to add a component that's easy for all of them to use, I would encourage looking at the Interact project in Interact. That's like a collection of React components that are made to be used in different notebook UI front ends. It's really easy to add a new MIME type renderer. Yeah.
Hi. So I wonder, how did you guys reach to that decision that you guys want to do the parallelization at notebook level instead of like have a library that you can try different parameters within a notebook without inside a notebook?
Yeah, so the question was around how do we come to the decision of branching on the notebook level instead of maybe branching within the notebook and iterating. And that actually has kind of been, I kind of see it as there's two design philosophies about how notebooks would evolve. One of them was the notebook as like a black box like function that I'm going to execute, or some larger system I'm going to execute. And the other was the idea that each cell would be that functional unit, and then you would reuse those cells somehow. Netflix ended up leaning on the notebook side because it was simpler. So the Kisset model kept it easier to reason about. It doesn't mean the other model is wrong or couldn't be built, but we kind of built tools for what we saw as the path of least resistance that would have the most reliability. One of the issues with trying to, one of the opinions Papermill takes is you're going to run this notebook linearly. Notebooks don't require you to do that from the UI side, but Papermill does. And this simplifies the problem and the reproducibility question a bit. In the other model, how you execute your cells, it becomes almost an acyclic graph of execution of your different cells. And notebooks didn't have a great way to express that DAG within notebooks today. So if we went that route where you want to like iterate on executing a cell, probably would have pushed more on building tooling around like setting up a DAG around inside the notebook object about how you're going to execute your cells and how they relate better. But we didn't go that way because we felt it was more complicated at the time.
On an adoption standpoint, when you have a new data scientist that comes in, I mean, how do you teach them essentially what are the best practices for, you know, here's, like you mentioned, a lot of people are not using source control, like the notebooks themselves, and what about the output, like people are trying to make that everywhere? I mean, is there access control for that? Or?
Yeah, so the question was, how do you onboard people onto these best practices, and how do you make their best practices actually best practices instead of maybe best practices? That's really, like, I can give you the Netflix answer. I don't think it'll translate to a lot of other places, and it's not perfect. I think in the Netflix case, we lean a lot on this concept of freedom and responsibility. So teams, individuals are free to do whatever they kind of want, but we expect that we've hired experienced people that are going to make responsible decisions. So oftentimes within an org or that team has made decisions about how to best onboard people. And so we try to provide the tools and notify, like inform people that these tools and patterns and documentation are someplace. And we leave the responsibility on the teams to figure out which of these they should keep track of and onboard their users with. There's some centralized onboarding, like we do training about the scheduler and notebooks for new hires every month. And for people who just don't know what it is. So we do a little bit of the training model and try to follow that way. It works pretty well within our culture, but within other cultures, you might want to do a different approach. Cool. I'll get to save my voice then. Awesome. I'm not sure how we are on time. Oh, we have another question. Okay.
So I work as a data scientist, and for most of the prototypings, we work with the Jupyter Notebook. So my question is that by using the Papermill, you're trying to like put your output in a separate notebook file. What's the advantage for that? Basically, for production, we have to somehow transform the notebook back to the Python script for the efficiency and other things. That I just wonder how or why you need to put that output on another file.
Yeah, so the question was around why separate the notebook when it goes to production, because the data science lifecycle lives within the same notebook. That's how they operate. Now I have to think about two notebooks that exist in the wild. There's a couple reasons we did this. One is it made data platforms be okay with us doing this. So that's actually a really compelling thing. It like crosses a bridge where you give this immutability guarantee about I ran this source and it resulted in this outcome. So from like a pure execution independent of what it's doing, that gives a lot of nice like security and replayability and debuggability for people who are outside of knowing what your notebook actually did or how it should operate. So that's one aspect. The other aspect that we have is that we wanted to have a very good recollection of how your notebook changed over time or how it iterated last time. So many times if something fails and a platform engineer or someone tries to help, they have to go look at what ran and figure out why it didn't work. And knowing what the last successful version is really handy because you can go look at the last successful run, compare it with the current run. That can tell you a lot of things about why something isn't working. Now, how does that feed back in like as a model or like how do you have a template? One thing that happens as a development side, if you schedule something with particular parameterization, usually when you want to try playing with it, you want that same parameterization. So many times people in the data science cycle would schedule their notebook, run it, and then you go see how it ran. And either they'll just copy the parameter cell back and run it because it's the same source, or they'll copy the whole notebook, and then when they're done, they'll just delete the parameter cell and save it. So therein the cycle is a little bit manual still. There could be tooling to make it less manual, and I think that's where a lot of the tooling is going, is smoothing over these edges. It's a little bit of a bump for a really big win to be cooperative with the rest of the ecosystem. Does that help answer the question? Okay. Awesome. I'm gonna see my voice, and I'll be around, so maybe I'll lose it anyway. But thank you, everyone, and hope you enjoyed.